Dr. Konstantinos Paraschakis from Gnosis Data Analysis, all the way from Crete, Greece. Konstantinos, please go ahead.
Hello, so it's already evening here. That's why it's a bit dark. First of all, can you hear me well, or should I use a headset?
No, we're good.
Yes, that's great. Let me open my presentation. Can you see my, no, you cannot see my screen yet.
You need to share your screen.
Okay, can you see my screen?
Yes.
Okay. So, my name is Kostas. I'm representing Gnosis Data Analysis, and I would like to thank the organizers for giving us the chance to present our analysis approach in this year's challenge. And of course, congratulate the other two winners for their success. First, I would like to take the opportunity and introduce our team to the symposium. So we're a University of Crete spin-off founded in 2013, and our area of expertise is the automated machine learning. And our main product is JADBio, that is just a data bio, perhaps the only online AutoML platform in the sense that it provides a fully automated machine learning analysis pipeline to the data analyst. And JADBio was actually the main tool I used to conduct the analysis on the challenge data. So before we go on to the analysis itself, let me try and convince you that JADBio was an appropriate platform for analysis of the kind of the FDA challenge. So we're talking about an AutoML platform that was originally designed for data coming from life sciences. Because if we think of the characteristics of such data sets, like small sample sizes and huge feature spaces, JADBio was designed exactly with those characteristics in mind. Also, we have put a lot of emphasis on the feature selection, as well as the interpretation part of the analysis. And I will show you some plots on this later. Another thing is, and that is common in all science, I believe, we are trying to achieve the best possible predictive performance with the smallest possible number of features. And the most importantly, everything is done fully automatically. Okay, now that we know the principles behind JADBio, let's take a closer look at the steps it takes to analyze the data. So after uploading the data, the user selects the type of analysis to perform, in our case classification, but it can also perform multi-class classification, survival analysis, and regression. And then one selects the target variable. And the last thing the user needs to do, actually, is to tell JADBio how extensive the whole analysis should be, whether it should be a fast, typical, or very extensive analysis. And that's it, actually, because the platform takes over from there and does the rest. So let's take a look at what JADBio does in the background. The first thing our AI does is look at some metadata like sample size and feature space and take some decisions regarding the kind of algorithms to be applied. Then we will available pre-processing types, feature selection algorithms, and predictive models, and performance evaluation of those. It selects the most appropriate given the data characteristics. The next step is to build a configuration pool. And what is a configuration? So one configuration is the combination of a certain pre-processing, a certain feature selection algorithm, and a certain predictive model. For example, for the third sub-challenge, the AI decided to apply about 2,000 configurations on the data, which it did in about 30 minutes time. So now we have a pool of configurations and we want to find the best one. And the best one means the most predictive one, of course. And we assess the predictive power of a configuration following a stratified and repeated k-fold cross-validation protocol. So once we have our winner configuration, we apply it on the full data set and return the details of the estimated model to the user. Let me take this up here. So now we have our final model, okay, along with the selected features. The model can be decision tree, random forest, a support vector machine, a logistic regression, or whatever, okay? And by the way, we're constantly trying to enrich the types of models that are included in JADBio, as well as the feature selection algorithms. Okay, the last step after training the model has to do with the phase 2 of the challenge. Apply to the test data for making predictions. I have to confess here that I employ the statistical language R to perform batch correction to the new data before I proceed to the actual predictions. But batch correction is something we also want to incorporate in JADBio in the not so distant future, we hope. Okay, and that's it regarding the challenge. Actually, the work is finished because we have the predictions that we wanted, okay? Because there was some time between the two phases, for the more impatient who cannot wait to find out how good the fitted model is, there are some treats. The first one is the unbiased performance estimation according to the BBC CV protocol. That is the bias bootstrap corrected cross-validation that is incorporated in JADBio. These are all tested methods that are proven to work well. So, and of course, there are numerous other plots that assist the interpretation of the model results. Okay, let's take a look at the results and some plots. From now on, we'll see the results based on the third sub-challenge, which was the most important one. But it was similar for the other two sub-challenges. Let's go to the first two plots. So the left-hand, I hope you can read the letters, the letters here, the names.
Yes, we can.
Yes, great.
Yes.
So the left-hand side plot lists all selected features. I repeat, those are all selected features according to their importance for the model. So in total, the platform selected 8 features. And the right-hand side plot displays the role of each feature in the model. That is the direction of association with the target variable. Increasing means positive correlation, decreasing means negative correlation. I shouldn't also forget to mention that our feature selection algorithm called SES typically returns several equivalent selected feature sets, equivalent in the statistical sense, of course, because this is important in some sciences. So let's move on to the model and its predictive power and associated metrics. Okay, here's the predictive model. On the right-hand side, we have the best model for the third sub-challenge data. This was a support vector machine with the displayed hyperparameters. And on the left-hand side, we have a collection of estimated performance metrics, like the ROC curve, the AUC, the accuracy, etc. There are several of them. And they are all evaluated on several thresholds, including their own optimal threshold, plus a 95% confidence interval for all of them. The final plots I would like to show have to do with the distinguishing strength of the selected features, so how well a job was done, and the predictive model. In the first plot, we see two distributions, one for each of the two classes of the target variable. So we're not talking about the predicted classes, but the actual ones, okay? The quantity in question is the probability of belonging to class 0 of the target variable. So the less overlapping the two distributions, the more the predictive power of the model overall. And I think it's clear from here that it was indeed a quite difficult task to solve. The last plot I'm going to show has to do solely with the distinguishing strength or distinguishing potential of the selected features. So nothing to do with the predictive model here. The two axes are the two first components of a principal component analysis on the selected feature set. The colors are again here for the actual class of each individual. So we have a so-called slide here. And I think the message here is similar to the one before. It was a hard task to fulfill. And let me conclude by mentioning a couple more features that we're planning to include in JADBio in the near future. So it will soon be able to incorporate user-defined algorithms. It will soon be able to handle pictures as input data, do batch correction, as I have mentioned already, and finally be accessed through public APIs. Thank you for your attention and for staying until the end to hear my talk.
Thank you very much, Kostas. It was very interesting. I guess we can take a look at questions one more time, but I noticed one of the questions which I can address to all three presenters in this session is if all of you can comment briefly on technology behind your modeling. Are you using a local cloud? Are you using AWS? What kind of computing resources were used by these three teams? Maybe we can go around and start with team number one, and then Kostas. How did you do it? Kanyak?
Yeah, I programmed our algorithm in C and C++, and it runs on our local server.
Okay.
Yeah. So our solution is almost exclusively done in R, and we are also porting, mostly in our like local machines, but we are also porting the pipeline to our cloud-based platforms. Yeah.
Okay. Konstantinos?
Yes, from my side, well, I think I have already answered this question during my talk. So yeah, we have this online platform called JADBio, which is a huge collection of algorithms, both for feature selection and predictive algorithms. And what it does, actually, it applies all algorithms on the data set. And then, following some evaluation protocols, it picks out the best one of them, the best predictive one.
Right. But in terms of the computational environment, were done on local servers and the cloud.
No, it was it's everything on a cloud.
Okay.
Yeah.
Okay. That's great. I don't see any more questions. So thank you very much again. Congratulations on top performance in this challenge. And I think, Subai, I can switch to you for conclusion of our symposium.